So just to go through the work packages, the schematic just really shows what we're trying to do here, because a gram-negative is different from a gram-positive. It has this additional outer membrane, which adds complexity. So any new antibiotic, it needs to get through the outer membrane, navigate the complexity of the cell wall, and then get through the inner membrane if the target happens to be cytoplasmic. All the time where you're trying to achieve that, there are efflux pumps that can just pump the molecules straight out again. So this is really quite a challenge for us to develop these new gram-negative agents. So work package 5 is really to integrate all the learnings from the other 4 work packages. Work package 1 is really going to be focused on creating much more accurate ways of measuring the various components of penetration, whether that be efflux, whether that be through bacterial membranes, whether that be through porins and so on. Work package 2 is going to focus more on porins. We know that these are the protein holes that are in the outer membrane of gram-negatives. Some antibacterials use those pathways to penetrate. We'd like to understand more about how we design molecules so they optimally traverse through these porins. Work package 3, bacteria have numerous active uptake pathways. This is how they get their nutrients. This is how they get things like iron that's essential for them to survive. What we'd like to explore in this work package is, can we actually use those transporters to actually deliver novel antibacterials to their target? So can we build in recognition features that will be recognized by these uptake pathways and then bring our novel antibacterials to their targets? And then the last work package is really ways of identifying and looking for new targets that can perhaps decrease the permeability of gram-negatives, whether that be through working perhaps on the outer membrane in a selective way, or by overcoming efflux. So the expected contributions from the applicants, we're looking for groups that have expertise in measuring cellular penetration. And again, just there may be some opportunities of translational learnings from mammalian systems into microbiology systems, so that's something that we would be open to. We're looking for groups that have expertise in and have been working on porin function and how you can design molecules to optimally penetrate through porins. So if there are groups working in that area, it's whether they would be interested in really translating that research into trying to create new antibiotics for gram-negative infections. Also, groups working in bacterial uptake pathways, and whether there's a great opportunity here to use that research as a way of delivering new antibacterials to their targets. Also, we're looking for groups with medicinal chemistry expertise, because there will be an opportunity to try and design in some of the recognition features for these uptake pathways into some molecules that we know just don't penetrate gram-negative. So there's some proof of concept studies that could be done there. And then finally, groups that have ideas of ways of either identifying new targets or validating new targets that could alter the permeability of gram-negative pathogens. Work package 6 to 8 is really focused on creating this database that's going to house the successes and the failures of what we've been doing in the industry and across academia and other areas as well. So the contributions from FPA members, we have a novel series of investigational antibiotics that could be used for data mining to see if there's some commonalities that seem to be very good for penetration into gram-negatives. We all have molecules that we know are very potent inhibitors of novel antibacterial targets, but we know they don't get into gram-negatives. These could be molecules that we would offer out to the groups to try and design in some of the recognition features so they get taken up by the active uptake pathway mechanism. So these can be proof of concept experiments for the approach. Also, the provision of molecules that we're working on gram-negative molecules, but often we don't know exactly how they get into a gram-negative, but if we knew exactly how they get into a gram-negative, that could help us optimize that activity. There's an opportunity for potentially running high-throughput screens on targets that, promising targets that look like they could decrease the permeability barrier in gram-negatives. And then the last point there is obviously providing the information to the database of our successes and our learnings. So finally, why would you want to be part of this? Well, I'm going to leave the patients to last in what's in it for the patients. From an academic researcher perspective, this is a great opportunity to participate, certainly from the clinical perspective, in the first antibacterial clinical trial consortium and be part of this leadership position that Europe is taking in addressing this problem. I think there's also some great opportunities to translate some more fundamental science, certainly around topic 2, into creating a better pipeline of antibacterials for addressing multi-resistant gram-negatives. And the other very key thing here, there's a huge opportunity of integration of learnings here. Because if you think of the spectrum of this project, it's going from everywhere from the complexities of a phase 3 clinical trial down to some fundamental science to try and understand more about how we get molecules into gram-negatives. So there's a huge spectrum and opportunity of learnings in many different areas. For small and medium enterprises, there's opportunity to evaluate promising diagnostics in clinical trials and training opportunities, and also contract research organizations with respect, certainly from the clinical trial perspective. And then finally, and most importantly, with the patients, I think you've probably seen some of the press releases that have come out around this IMI project. There's clearly a lot of interest in this project, but a lot of those press releases really make this point that antibacterial resistance really threatens our ability to tackle life-threatening infections, but it could, in the future, really threaten our ability to treat common bacterial infections. So this IMI proposal, I think, creates a concrete step forward in really increasing our preparedness for dealing with the multi-resistant pathogens that we have to tackle today, but also the unpredictable threats that could be around the corner in the future. So that was all I was going to say. Thank you for your attention. I don't know whether we're taking questions now or... Okay, thank you then.
So thank you, David, for the presentation. Now, before we open the floor for discussion, I will invite Nathalie to present the procedures for this call, for the application. So important information for the applicants. And so after this whole picture of this call, then we will open the floor to questions on both subjects.